Hello everyone, in this session we will discuss the relation between Bitcoin and blockchain. There are many people around the world who know blockchain just because of cryptocurrency and they somehow believe these terms are synonymous. Here's an easy way to think about the difference. Imagine you're in a casino, you enter the building and exchange your cash for chips. You can use these chips to gamble casino, but outside the building they have no legitimate purchasing power. In this example, the casino chips are cryptocurrency coins and the casino is the blockchain network, providing an ecosystem of participants and putting coins in the play and allowing them to be transacted. Now let us compare these two in tabular form. As you can see, we have made a table for you to differentiate between blockchain and cryptocurrency. First, we compare them by their nature. Blockchain is a technology that records transactions, whereas cryptocurrency is a tool or asset used in virtual exchanges. Second, we have compared them by their use. Blockchain is used to record transactions, whereas cryptocurrency is used to make payments, investments, and storing of wealth. Third parameter on which we have compared both is the value. Blockchain has no monetary value, but cryptocurrency does have a monetary value. Fourth parameter is mobility. Blockchain cannot be transferred, but cryptocurrency can be transferred. So what is Bitcoin? Bitcoin was first introduced by Satoshi in his white paper, which was detailed in 2008. Bitcoin was the first cryptocurrency that came into the market. In 2008 he started with Bitcoin, and in 2009 he made it public. As we discussed before that the blockchain network uses transactions to create other transactions, Bitcoin uses those transaction mechanisms. We call them on-spam transaction outputs. If it makes a transaction with B, then B is going to use the transaction which A has made for him to create new transactions. Supposedly it makes a transaction of 2 Bitcoins to a friend B, and B is using the transaction that A has created to make a transaction of 2 Bitcoins to another person C. Whenever you were making the transaction, the whole amount which you own is being transferred to the other end. On the other hand, the algorithm runs calculations and subtracts the amount which you want to transfer, and then the remaining amount is given back to you like another transaction, and you can use that transaction to make other transactions. There are scripts which help the validation process for Bitcoin. So they validate that whether Charlie has 5 Bitcoins to transfer to his friend James, whether the friend James has a valid address which is the valid account inside the Bitcoin network where you want to make the transaction, whether these transactions being recorded with mainchain or is this happening in a peer-to-peer off-chain network. So these are the things which is script checks. So miners make verification and validation format for the Bitcoin transactions. We also have metadata in Bitcoin. Metadata is the data associated with the transaction, so currently in Bitcoin, you can set up to 1 megabyte of data with your transaction. Metadata, it's just the details about the transaction and any additional comments you want to add or any additional information you want to put in with a Bitcoin transaction. Metadata can also be used as the storage unit. You can use it as a database unit where you are storing some data because as a transaction, it is going to happen over the Bitcoin network. That's going to be a permanent transaction you cannot change or tamper with, and you can use the data within your applications or projects. If we talk about the consensus algorithm, Bitcoin uses a proof-of-work algorithm. Proof-of-work algorithm with the timestamp of the transaction validates the block. In proof-of-work, any transaction happening on the Bitcoin network has some associated puzzle with it. By saying puzzle, we are saying that certain algorithms are running behind that, so they have specific cryptography functions, but there is one major random nonce. Nonce is a random number which is not shared with anyone, so the miners try to guess that random number. Miners who want to confirm the transaction try to guess that number, and when any of the miners come even near to that number, they confirm the transactions for the network, and once they confirm the transaction in the Bitcoin case, they receive 6.25 BTC for the confirmation of that transaction. They also make it public to other miners that the transaction has been confirmed, so now you can move to the next transaction and see whether you can guess the nonce, the random number in that transaction. So that's how the proof-of-work algorithm works for Bitcoin. The Bitcoin protocol was established by Satoshi. As per Bitcoin, there can only be 21 million Bitcoins available in the market. Currently there are around 18 million Bitcoins in circulation, and with mining, the rest of the 21 million will become usable by the year 2140. Bitcoin is an application of blockchain. We need to remember the blockchain is simply a technology or a concept which is implemented through various channels, just like Google and Facebook are applications of the World Wide Web and the communication protocol or networking. Similarly, Bitcoin is an application of blockchain among the hundreds of other applications running on the internet. One more application of blockchain that has become quite famous is Ripple. Ripple allows multiple banks to transit amongst each other in real time without involving a trusted third party. Currently, the Ripple network has more than 80 banks connected worldwide, allowing them to transfer a real currency amongst each other through the blockchain network. Another popular implementation of blockchain is IOTA. IOTA is an Internet of Things blockchain which allows different IoT devices to talk to each other and log data simultaneously. Stratos is also an implementation of blockchain. They provide you with a Stratos wallet, which is basically a hyperledger blockchain or hyperledger fabric. Now, as you know, most blockchains have some coin or cryptocurrency circulating to reward the network and make it secure. Alright, so now let's see the features of Bitcoin. Bitcoin is a decentralized system. When Satoshi created the Bitcoin network, he wanted Bitcoin to be available to everyone. Bitcoin is a permissionless network where nodes work together to form this network, and all the currency in process, transactions, everything is part of that. Central authorities try to put up some laws over the currencies and circulation, but Bitcoin can't be a part of that. So that's one of the major things. Then there is a simple setup process. So when you go through a regular bank, you have a whole lot of processes to follow in order to create an account. You need to verify your KYC, you need to submit your private documents, and then only you'll have your account, but Bitcoin solved this issue. With Bitcoin, it's just a straightforward process to connect to the network and create your account having private and public keys. You can use that account to create all the transactions, and you can use that account even in the payment itself. Then the third point is anonymous and transparent usage. Satoshi wanted to create something which is transparent. So he created a public ledger which is shared by everyone. An open public ledger is there to maintain the authenticity and validity of transactions happening in the Bitcoin network. Blockchain records every transaction for the network participants to see and verify, minimizing the chances of fraud manipulation. The current transaction fee is huge, and it's only because the people who are using it have created the value of Bitcoin. Then there is the fast network process. Miners are quick to confirm transactions happening on the blockchain. They have powerful CPUs, large GPUs, working behind the blockchain. So miners make sure this complete process happens very fast, so whenever we do any transaction, the network tries to solve that and confirm that faster as compared to bank authorities, rather third parties. The transactions in Bitcoin are non-refundable. Non-refundability refers to the fact that once the transaction is being used and it cannot be used again. Suppose A had 5 Bitcoins and A made a transaction to be a 3 Bitcoins using the transaction of 5 Bitcoins. So I can't use that again. So now when the blockchain process calculates that A has to return 2 Bitcoins to B, that is a separate transaction compared to the 5 Bitcoins. The transaction of 5 Bitcoins is used, and now A has a new transaction that shows that A has 2 Bitcoins and can make a third transaction to somebody with 2 Bitcoins. Bitcoin is the cryptocurrency whose ledger is maintained by the blockchain network openly, and the numbers dragged are visible to everyone. So it is nothing more than a digital number which is being tracked. People often ask questions like who put their money into Bitcoin, or who paid the initial money, or who is stupid enough to have $35, $40 million in Bitcoin. The answer is no one. Value of Bitcoin increased due to the huge demand and a limited supply. You'll understand this better with an example. Let's say there are 100 golden unicorn toys and there is no way to generate more of these toys or reduce the number. This means that the 100 golden unicorn toys will always be limited to a quantity of 100 only. Never will it become 99 or 101. Now, if everyone in this world wanted to possess the golden unicorn toy, the demand would increase but the supply remains unchanged. So it becomes a form of currency because of its rare value and people can start treating with it. After all this, it would still remain a golden unicorn toy, but its value would skyrocket. Similarly, everyone needs gold, and because of that, gold has such immense value, but it still remains a precious metal. Again, ruby is a beautiful stone that is expensive because everyone wants it. Now let's imagine a hypothetical situation where one day no one in this world wanted gold or oil. What do you think would happen that day? Naturally, the value of gold and oil would become zero because of lack of demand. So you see, it is all about supply and demand. In Bitcoin, the supply is capped at 6.25 Bitcoins per block, but there is a huge demand for it and no further supply. Hence we see the value increasing constantly, which began with 1 cent, 2 cents to $1, $10, $100, $200, $300, and almost $10,000 in July 2019. That is why the value has increased over time and not in one day. Now we hope it is clear that Bitcoin is a cryptocurrency while blockchain is the technology behind it, and if you are working on blockchain and learning blockchain, then you are not actually learning cryptocurrency but learning how cryptocurrency works. This doesn't make you a person dealing with something which the government of different countries made banned, because technically the logic of concept of blockchain cannot be banned as long as the internet is thriving. For example, it is not possible to ban technologies or data structures. Data structure is a concept which is actually written in the book. You can read the concept in the name structure to build a database, a programming tool, or whatever you want to build. Data structure is a logical concept. Similarly, blockchain is a concept on which cryptocurrency is based. Now, how Bitcoin mining is done. For a miner to create a valid block, following work has to be done. A miner has to collect and verify transactions which are not yet included in blockchain. It can be any number of transactions, just that the total size should be within 1 megabyte. For each block, there are often several thousand transactions included in it, depending on how much data each transaction stores and also if there are pending transactions. Now, to create a candidate block which can be appended to the blockchain, miners solve the complex computational problem, called as proof of work. The result is a 64-digit hexadecimal hash of the block that is less than or equal to the target hash. To get to it, a miner's computer produces different hashes of the block by changing its nonce value at the rate depending on its computational capability. It could be megahashes per second, gigahashes per second, or even terahashes per second. Miner does it by guessing different 64-digit numbers until they arrive at a solution, just like gambling. The difficulty level is producing a hash below the target 1 in 13 trillion. To put that in perspective, you are about 44,500 times more likely to win the jackpot with a single lottery ticket than you are pick the correct hash on a single try. Fortunately, mining systems, used by miners, are much faster in being able to produce many more hash possibilities than that. Nevertheless, it requires massive amounts of energy and sophisticated mining rigs. It depends upon the mining difficulty level, which is adjusted every 2016 blocks or roughly every 2 weeks in Bitcoin. The difficulty of producing a block is adjusted to keep the rates of mining constant. So if powerful miners are competing for a solution, the more difficult the problem will become, and if the computational power of the network lowers in case miners withdraw, the difficulty is decreased to make the job easier. That was all for this session. Thank you.